So this lesson covers the mole and molar mass, and for this lesson you want to have a calculator and a periodic table handy for it. So what is a mole? You might have heard of a mole before in terms of a small furry animal or a dark spot on your skin, but this is going to be the chemistry definition of mole. So up until this point, we've looked at measuring mass, we've looked at measuring volume, but the other way we can measure things is by looking at counting pieces or counting particles. We can measure the mass in grams, the volume in liters, but the way we count pieces is in moles. So moles, which is abbreviated as MOL, you only get to chop the E off the N, is defined as the number of carbon atoms in exactly 12 grams of carbon-12. A mole is 6.02 times 10 to the 23rd representative particles. We can think of this as a very large dozen. Okay, so just like if I say I have a dozen eggs is 12 eggs. Or if I say a dozen cookies, that's 12 cookies. 1 mole is 6.02 times 10 to the 23rd things. So if I'm talking about a mole of cookies, that's 6.02 raised to the 23rd power, 10 to the 23rd power of cookies. It's a whole lot of cookies. I could be talking about 6.02 times 10 to the 23rd puppy dogs. Okay, that would be a mole of puppy dogs. That would be a lot of puppy dogs. Okay, there's another term for 6.02 times 10 to the 23rd, and that is Avogadro's number. And so it was named after Avogadro. He didn't discover the number, but he did do a lot in science for it. And if you look in my classroom, there's actually a thing from Trader Joe's about Avogadro's guacamole. And about how it tastes like it has 6.02 times 10 to the 23rd avocados in it. So this is going to be a number that we're using very often now. Now we've talked about molecular compounds, and their smallest particle is called a molecule. And remember, with molecular compounds, this is for covalent bonds. Okay, and covalent bonds are 2 or more non-metals. And when we have ionic compounds, it's called a formula unit. And with our ionic compounds, we have an ionic bond, and that is a metal and a non-metal. If you don't remember this, you should write it down. Okay, a metal and a non-metal. If we're talking about an element, it's an atom. Okay? So this is still all terminology. When we say representative particles, this is what we're talking about. We're usually talking about molecules, formula units, or atoms. It's just this general term for it. Now, I keep bringing it up. We want to make sure we remember the 7 diatomic molecules. Your Brinkelhoff, I have no brighter clever friends, your hockey puck and hockey stick. Okay, and remember, they are not diatomic unless you write the 2's after them. Okay, so chlorine, fluorine, chlorine, iodine, and bromine. You should know by now I mark you wrong if you just write H, N, O, etc. So more about the mole. Okay. We want to use this concept. A mole of carbon dioxide contains Avogadro's number of CO2 molecules. So, if we are thinking about this here, let's think about our terminology. Each CO2 molecule is made up of how many atoms? So, you've got 1 carbon. Whoops, let's make that look more like a 1. 1 carbon and 2 oxygen. So each CO2 molecule, is made up of 3 atoms. Okay. We want to be sure that we're understanding our terminology as we're adding new vocabulary to this. So, how many oxygen atoms are in calcium carbonate? CaCO3. Okay. This 3 afterwards, after the oxygen, represents the 3 atoms. Oh, I'm pushing too hard there. Atoms. Okay. How about the next one with aluminum sulfate? Tell me how many oxygen atoms are in aluminum sulfate. Hopefully you got 12 atoms, okay? The 4 and the 3 multiply. This is the same as saying that I have aluminum, and I have that SO4 molecule 3 times, okay? So it's the 4 oxygens added up 3 times. So what's new to us also is this concept of molar mass. And molar mass is called the mass of 1 mole. And that is the atomic mass of an element in grams. We're going to start using more of the information found on the periodic table. So now's when you really want to have your periodic table handy. If you take a look at your periodic table, sulfur has a mass of 32.07 atomic mass units. We haven't really looked at these numbers since Unit 2. Okay, when we did average atomic mass. So it's been a long time since we've played with those numbers. And at that time, I told you that the units are, not average. Okay, so I told you at the time that the name is atomic mass units. That's what the AMU stands for. Okay, so what we have now is you can also think of that number on the periodic table is the number of grams in 1 mole. So if I were to count out 6.02 times 10 to the 23rd atoms of sulfur, they would weigh 32.07 grams. Okay, so that's what that's saying there on the periodic table. It's another way to look at that. So again, I want you to look at your periodic table, and I want you to find some of the numbers for me. So first, I want you to find what the molar mass of carbon is. So you should take a look at your periodic table, and you should be finding 12.01 grams per mole. We want to use grams per mole now because I asked you what the molar mass is. That's the mass of 1 mole of this. If I'd ask you the mass of 1 atom, I would say 1 atom of carbon has a mass of 12.01 AMUs. That's the distinction there. So take a look and find oxygen. Give me the molar mass of oxygen. Now, you might have just written 16. What I want you to write is 16.00 grams per mole. We have talked about significant figures last semester, and it's important to include those 2 zeros on the end because those zeros are significant. So scientists worked hard to measure the numbers that precisely, so we want to use them because when we start doing calculations with them in a few minutes, okay, those zeros become important. So it just becomes a good habit to write them down. And I really like us all using the same periodic table in class because then we all get the same answers when we add it up. You'll find that some periodic tables will take things out to more decimal places and add things up differently. So my next question to you is, does a mole of carbon and a mole of oxygen contain the same number of atoms? Okay. And hopefully you realize they do. Okay. 1 mole of carbon does have the same number of atoms as 1 mole of oxygen. The difference between these is your carbon has 6 protons and 6 neutrons and 6 electrons, which causes it to weigh less than oxygen, which is element number 8, and it has 8 protons and 8 neutrons and 8 electrons. So that's why the oxygen has a greater molar mass, even though they both contain 6.02 times 10 to the 23rd atoms. They have to. That's how a mole is defined. Okay. So this is building us to this idea of molar mass, coming a little bit closer. So the molar masses of any two elements have to contain the same number of atoms. But that's great. We're not always dealing with atoms, though. Often we are dealing with compounds. And so with chemistry, it's just a simple addition problem. So in order to measure the molar mass of a whole compound, we just add up the individual masses of each atom in the compound. Okay, so if we wanted to take a look at sulfur trioxide, which is SO3, okay, what we would first do is get the mass of each one of the elements, which we've already done as part of this lecture. Okay, we've already gotten those parts. So the mass of sulfur is 32.07 and the mass of oxygen 16.00. And I add them up. So I have 1 sulfur, 32.07, 3 times 16, that's 80.07. The units are G/mol, grams per mole. And we want to remember our rule for addition and subtraction for sig figs, which means you count the spots after the decimal. So I have 2 spots after the decimal here, 2 spots after the decimal here. When I add them all up, I still have 2 spots after the decimal. So we're good. So what this means is we would say sulfur trioxide has a molar mass of 80.7 grams per mole. Or if I were to count out 6.02 times 10 to the 23rd molecules of SO3, okay, it would weigh 80.07 grams. That's how these numbers relate to each other. Okay, so now we want to practice some of the molar mass calculations. Your two main things that you need to get from this section is how a mole is defined and then how to calculate molar mass using the periodic table. So first up, what is the molar mass of water? H2O, a nice little sample problem for you here. This is a really nice way to set it up. This is going to help you out when you are doing some problems later on. So you've got 2 hydrogens, hydrogen off the periodic table is 1.01, 1 oxygen, 16.00, and then I can add those 2 numbers up, and that gives me 18.02 grams per mole. Again, you need to have the units for this one. Okay, the next problem here. What is the molar mass of hydrochloric acid? Now you're going to solve this one. So when we get the numbers off the periodic table, we already had hydrogen 1.01, chlorine 35.45 grams per mole. I just have one of each and I add them up. And again, the rule for addition and sig figs is counting spots after the decimal. So I have 2 spots after the decimal here, 2 here, and then 2 right there. So you're going to find with significant figures and calculating molar mass, it's going to be real simple because it's always going to be 2 spots after the decimal. Okay, let's do one that involves a few more numbers. What is the molar mass of aluminum oxide, magnesium hydroxide, and then barium hydroxide octahydrate? So you are going to tackle all 3 of these problems. They're each going to come up, and the video is going to pause, and you're going to give me an answer, and then we'll check it. So the first one, the molar mass of aluminum oxide, Al2O3. So here's our numbers when we add them up. You should have gotten 101.96 grams per mole. Please go ahead and enter the units when you're doing this. We want to practice writing the units on these things. Okay. Notice for the oxygen, I did 48.00. Again, you just want to get in the habit of writing the proper number of significant figures. Okay, let's try the next one. What is the molar mass of magnesium hydroxide, MgOH2? So for this next one, now when I go to count this out, this 2 distributes on everything in there. The 2 distributes on the oxygen and the hydrogen. So I've got 1 magnesium, 2 oxygen, 2 hydrogens. I multiply these out, I add them all up, and you should have gotten 58.33 grams per mole. Now, the last one's different, okay? What is the molar mass of barium hydroxide octahydrate? And so we've got this symbol here, this dot, okay? And this dot in chemistry typically indicates a hydrate. Okay, so the hydrate is these waters, and the oct in the octahydrate means 8 waters. Okay, but in math, I know you guys are used to seeing a dot meaning multiply, but in chemistry, what this dot actually means for us is plus. So this is going to be barium hydroxide plus 8 waters. So I would add up the barium hydroxide and then add up the 8 waters and then get your answer. So this is one way you could solve it, okay? You could do the barium, the oxygen, the hydrogen of the hydroxide, and you can distribute this 8. That would give you 16 hydrogens, and then the 8 also distributes on the oxygen, and then 8 oxygens that way. And you could add all those numbers up, and it would give you 315.51 grams per mole. So that is the correct answer. Now, that's not the only way you can solve it. Another way you can solve it is like this. You can, again, do the barium and the hydroxide right there, the barium, the oxygen, and the hydrogen, and then you can add up 8 waters. So here I have 8 waters. 1 water is 18.02, and I multiply it by 8, and I get the same number of 315.51 grams per mole. So what these hydroxides are is you have this molecule of BaOH2, and it is surrounded on all sides by 8 waters. So 1, 2, 3, 4, 5, 6, 7, 8. So those 8 waters surround it. There's other things that you've dealt with. Copper sulfate pentahydrate earlier in the school year was also an example of a hydrate.